All right, welcome to another warm-up. This is going to be, I think, a quick one. I've added in a little bit of bonus content that I have thrown into this next section. Good to get trigonometry in our lives a little bit sooner to give you a little bit longer to remember it and practice it. We'll do some real proofs of these later. So pause the video, give it a try. All right, I think I can do this one without even moving these around. Let's see if I can do it. This is well, it's not a polynomial because I've got this e to the x and this square cube root of x, but I can still do them term by term. So let's do it term by term. 3x to the fourth, the 4 comes down, multiplies the 3, and I get 12x. The 4 goes down by 1, and I get a 3. Plus, the 2 hangs out. It's a constant multiple. E to the x, the derivative of that is e to the x. Nice and easy. Plus, the cube root of x, little scratch work on the side here. Cube root of x can be written as x to the 1/3. So if I bring down that 1/3, I subtract 1 from a third, I get negative 2/3, and I'm done. Those are equal. Not bad. This second one takes maybe a touch of work, I think. So I'm going to go ahead and rewrite the stuff on the inside. That's kind of the point, is both of these, it helps if you do a little bit of algebra. So let's first square this out. X squared plus 8x plus 16 minus, and then it helps if we split this numerator up over the denominator. So x squared over x cubed is x to the negative 1. 2 minus 3 is negative 1. And then the minus distributes. And then 5x over x cubed looks like 5x to the negative 2. All right, so that's really the trick on these, is doing a little bit of algebra to make it into a form that we can work with easier. Even when we get more rules to deal with these, this will still be the fastest way to do it. So now I'm going to go term by term. I'm going to say this is 2x plus 8. Pretty fast. What happens to the 16? It just goes away. Derivative of 16 is just 0. In fact, I'll write it this time. Minus the negative 1 comes down. So negative is plus. X to the negative 2. The negative 2 comes down. Plus. 2 times 5 is 10. X to the negative 3. Ta-da! All right, notice how I'm being a little careful with my equal signs as well, and with this d dx's. I never want to write that a function equals its derivative, but this is saying that the derivative equals that function at the end. Nice. That was your review from last time. You haven't learned these next two things yet, but I thought I would introduce them and we can talk about why in a future section. They're so nice, so being able to use them is going to get us some better examples. The derivative of sine of x. Sine of x is a nice periodic function, so its derivative should also be periodic. Not only periodic, it's very familiar. It's just our old friend, cosine of x. How nice is that? So then we could ask, what's the derivative of cosine of x? Well, it's negative sine of x. All right, so a little negative in there, otherwise about as nice as you could want. We could keep going and say, what's the derivative of negative sine of x? And that would be negative cosine of x. And we could say, what's the derivative of negative cosine of x? And that gets right back to positive sine of x. Great, that's it for the warm-up for today. Enjoy the lesson.